Hello guys, welcome back to Upward HVAC. In this video I'm going to talk about air-cooled chillers vs water-cooled chillers, and we are going to see some comparison aspects for these types of chillers. Chillers are being used in comfort air conditioning in small or large commercial buildings and for process cooling purposes as well. Chillers play a vital role in chilled water air conditioning system as they serve the chilled water to create the required cooling effect in the space. They produce chilled water or refrigerant, which is transported by pumps and pipes to the cooling coils of conditioning units. There are so many advantages and disadvantages associated with air-cooled or water-cooled chillers. We are choosing the appropriate type according to our requirements, and also cost is a primary factor as well. There are some points, positive and negative, that I've shown in this video about both type of chillers. You have to consider these points when deciding between air-cooled and water-cooled chillers. Now let's begin our today's topic, air-cooled chillers vs water-cooled chillers.
So our topic is air-cooled chillers vs water-cooled chillers. We have many aspects. We need to see the differences between these two types according to that aspects. We have durability and efficiency. We know that air-cooled chillers are less efficient than water-cooled chillers, and that because the air-cooled chillers are depending on the dry bulb temperature for cooling the condenser, while the water-cooled chillers are dependent on wet bulb temperature, which is less than dry bulb temperature. According to this diagram here, we can see easily that for any temperature, the wet bulb is less than the dry bulb. That's why the condenser is going to cool more in the water-cooled chiller. That's why it is more efficient than air-cooled chillers. Operation cost and noise. The air-cooled chillers are more noisy because they have big fans to cool the condenser, and it has more operation cost, while the water-cooled chillers are less noisy and less operation cost. Capacity range. The air-cooled has two categories, from 70 to 125 tons and from 120 to 500 tons for some of the centrifugal and screw chillers. As we see here in this screw compressor chillers series, we have some manufacturers range starting from less than 50 reaching to 500. Water-cooled chillers, the range is between 120 to 4,000 tons. That means for 50 to 14,000 kilowatt, which is more range, more than the air-cooled chillers. The initial cost is cheaper for the air-cooled because it hasn't the pumps and the condensing pumps, as well as the water cooler or cooling tower. That one is not available in the air-cooled chiller. That's why it is less and cheaper than the water-cooled for the initial cost, while the water-cooled is more expensive. annual water consumption, the air-cooled are not reliant on water at all. That's why it is zero in the water consumption. While the water-cooled chillers dependent on water. That's why it need plenty of water. According to here, this table, we can see the cooling tower required about 497,000 cubic meter, while the air cooled not required at all water. The maintenance and life cycle. The air cooled are less maintenance and repair, but life cycle span is less, while the water cooled are demand more maintenance and long lifespan because of chemical treatment requirement, water quality, and it can be installed indoor. That's why the lifespan is more. The chemical consumption for air-cooled is zero, and there is chemical consumption for water-cooled chillers. Space requirement for air-cooled is more because it's bigger than the water-cooled chiller, and it is less for water-cooled. Energy consumption requirement for air-cooled is more. It required around 1.25 kilowatt per ton, while it is less for the water-cooled, around 0.55 to 0.8 kilowatt per ton. Pros and cons of air-cooled chillers. Air-cooled chillers fit better for cooling plants of up to 2 megawatt capacity for cold or mild climates and for regions where water resources are limited. Pros: lower initial cost for the cooling plant, water-saving solution, small installation area required, easy and expensive maintenance. Cons: generally lower energy efficiency, capacity per unit is limited at about 2 megawatt cooling. Here also we can see some comparison. Water-cooled chiller advantages: high efficiency, custom selection on large sizes, large tonnage capacities, indoor chiller location, longer life. Air-cooled chillers advantages are lower installed cost, quickly availability, no cooling tower or condenser, pumps required, less maintenance, no mechanical room required. Pros and cons for water-cooled chillers. Water-cooled chillers are perfectly suitable for large cooling plants, e.g. for district cooling. Pros: high energy efficiency, especially when paired with open-loop cooling towers, availability of large capacity units. Cons are high maintenance costs and high water consumption, particularly when running in conjunction with open loop cooling towers. Large installation area required for a cooling plant. Legionella risk. This is a type of bacteria affecting the cooling towers because cooling towers are often part of the centralized air cooling system for buildings or industrial processes. Importantly, these structures contain water and fans to remove heat from the air. In this process, inadequately maintained cooled towers can create aerosols, droplets of water in the air that contain Legionella bacteria. The heat rejection fans in cooling towers then spread these bacteria. And regarding the water availability, since air-cooled chillers do not require water, they are preferred for locations where there is a shortage of water or water is very expensive. Problem of fouling scaling. In water-cooled chillers, there is a problem of scaling caused due to hard water. This scaling directly affects the efficiency and performance of the chiller. So in water-cooled chillers, we have to supply pre-treated water to avoid scaling. Condenser water treatment to eliminate the contaminant such as bacteria or algae. Water-cooled chillers need to treat condenser water every now and then. Here this curves showing the comparison between air-cooled vs water-cooled chillers performance. You can see that the water-cooled are more energy efficient comparing to the air-cooled chillers for the same capacity and the same temperature ranges. We have another type, magnetic air-cooled chiller. It is in between. And this also table showing the comparison between the efficiencies of the air-cooled and water-cooled, which is electrically operated. Either it is positive displacement type or centrifugal type, and we can see the best type is among all of these is the centrifugal type, water-cooled, which is a centrifugal type, and especially in the part load condition, compared to the positive displacement as well as the air-cooled type. Another diagram from Ashray showing also the differences of different type, air-cooled with air-cooled type and water-cooled type, and water-cooled with the fluid economizer, and the glycol-cooled, which is water-cooled type also mixed with the glycol, and the efficiency, net sensible cooling capacity, which is very less in the glycol type comparing to the water-cooled type and the air-cooled type.